Have you ever wondered why Earth's greatest cliffs and stone towers feel both eternal and fragile? Tonight on Unearthed Secrets, we explore collapsing coasts, vanishing arches, and forests of stone shaped by time and tide. Before we begin, please like, subscribe, and tell us where you're watching from. The Earth is changing. The edge of the Atlantic. The Cliffs of Moher rise abruptly from the Atlantic Ocean along the western edge of Ireland, forming one of the most dramatic natural boundaries in Europe. Stretching for nearly 14 kilometers along County Clare's coastline, these cliffs stand as a vertical record of deep time, violent oceans, and human presence shaped by proximity to the edge of the world. At their highest point, near O'Brien's Tower, the cliffs rise over 214 meters above the sea, creating a sheer wall of rock where land simply stops and the Atlantic begins. Unlike mountain ranges that announce themselves from afar, the Cliffs of Moher often reveal their full scale only when one is already close. From inland fields, the land appears gentle, rolling grass, stone walls, grazing cattle. Then, with a little warning, the ground breaks away into empty air. This sudden transition has defined the cliffs not only as a geological structure, but as a psychological one. For centuries, they have marked a limit between safety and danger, known land and unknown ocean, permanence and erosion. Geologically, the Cliffs of Moher are composed primarily of sedimentary rock laid down over 300 million years ago during the Carboniferous period. At that time, Ireland lay near the equator, submerged beneath the shallow tropical seas and river deltas. Layers of sandstone, shale, and siltstone accumulated slowly, grain by grain, forming thick deposits that hardened into rock. What appears today as a vertical face was once a horizontal landscape, shaped over unimaginably long spans of time. The cliff's distinctive horizontal banding is visible even from a distance. Darker shale layers alternate with lighter sandstone beds, each representing different ancient environments: quiet seabeds, fast-flowing rivers, floodplains. These layers record changes in climate, water depth, and sediment flow long before human history began. When the Atlantic Ocean began to open millions of years later, tectonic forces fractured the land, and relentless wave action began carving the coastline into its present form. The Atlantic is the true architect of the Cliffs of Moher. Waves driven by storms from across thousands of kilometers strike the base of the cliffs with enormous energy. Over time, the sea exploits weaknesses in the rock: faults, fractures, softer shale layers, slowly undercutting the cliff face. Rockfalls are frequent, though often unnoticed from above. Entire sections collapse into the sea, reshaping the coastline year by year. The cliffs retreat inland at a slow but measurable pace, reminding observers that even structures of immense scale are temporary. Despite this constant erosion, the cliffs remain remarkably stable in appearance, giving an illusion of permanence. This contrast between apparent solidity and inevitable loss has contributed to their powerful emotional impact. They look eternal, yet they are always changing. The cliffs have long played a role in Irish history and folklore. Long before they became a tourist destination, they were part of a lived landscape. Fishermen worked from narrow inlets at their base. Farmers grazed livestock dangerously close to the edge. Watchmen scanned the horizon for approaching ships. During periods of invasion and conflict, the cliffs served as natural defenses, discouraging landings along much of the coast. One of the most recognizable features along the cliffs is O'Brien's Tower, built in 1835 by Cornelius O'Brien, a local landowner who sought to attract visitors to the area. The tower stands near the highest point of the cliffs, offering panoramic views on clear days across the Atlantic to the Aran Islands and Galway Bay. Though modest in size, the tower represents one of the earliest attempts to formalize the cliffs as a place of visitation rather than survival. Long before tourism, however, the cliffs were woven into myth. Irish folklore speaks of heroes and tragedies tied to the edge. One legend tells of the warrior Cuchulain's pursuit of the sea witch Mal, who fell from the cliffs and drowned below, giving the cliffs their name, Ailt and Mothair, the cliffs of the ruined woman. Whether myth or metaphor, the story reflects how deeply the landscape has shaped narrative imagination. Ecologically, the Cliffs of Moher form one of Ireland's most important seabird habitats. The sheer rock faces provide ideal nesting sites safe from most land predators. Over 20 species of birds breed here, including puffins, razorbills, guillemots, kittiwakes, and peregrine falcons. At peak season, tens of thousands of birds occupy the cliffs, turning them into a living, moving ecosystem suspended between rock and sky. Puffins, perhaps the most iconic residents, nest in burrows atop grassy cliff edges, commuting daily between land and sea. Their presence has become synonymous with the cliffs, yet they depend entirely on the fragile balance of marine life below. Changes in ocean temperature and fish populations directly affect their survival, linking the cliffs to wider environmental systems far beyond Ireland's shores. Below the cliffs, the ocean is rarely calm. Swells roll in relentlessly, shaping not only the rock, but the soundscape. Even on clear days, the constant roar of waves rises from below, echoing upward. In storms, the Atlantic transforms the cliffs into a theater of force, waves exploding against stone, spray rising hundreds of feet, wind tearing across the edge. These conditions are both spectacular and dangerous, reinforcing the cliff's reputation as a place that demands respect. Human interaction with the cliffs has not always been cautious. Over centuries, the edge has been both refuge and risk. Stories exist of shipwrecked survivors climbing narrow paths to safety, and of others lost to missteps or sudden gusts of wind. In modern times, safety barriers and designated paths attempt to reduce danger, but the cliffs remain inherently hazardous. The land here does not forgive distraction. The Cliffs of Moher have also become a cultural symbol far beyond Ireland. They have appeared in films, documentaries, and photography that emphasize their dramatic isolation. Yet this visibility brings pressure. Millions of visitors now arrive each year, walking paths that were once quiet. Managing this impact has become a priority. Conservation efforts aim to protect both the geological integrity of the cliffs and the ecosystems they support. The modern visitor center is built to the landscape, designed to minimize visual intrusion. Paths are routed away from the most unstable edges. Access is controlled in sensitive areas to protect nesting birds and prevent erosion of fragile grasslands. These measures reflect an understanding that the cliffs are not simply scenery, but a living system under stress. Scientifically, the cliffs continue to be studied for what they reveal about Earth's history. Fossils embedded within the rock layers provide evidence of ancient marine life. Trace fossils, burrows and tracks left by organisms, record behavior rather than bodies, offering rare insight into prehistoric ecosystems. Each exposed layer is a page in a geological archive that stretches back hundreds of millions of years. Weather patterns along the cliffs are extreme and unpredictable. The Atlantic brings rapid changes. Clear skies can give way to fog, rain, and high winds within minutes. This volatility has shaped both natural processes and human responses. Traditional clothing, stone buildings, and farming practices in Clare reflect generations of adaptation to a harsh coastal climate. Standing at the edge of the Cliffs of Moher, one becomes acutely aware of scale. The horizon stretches endlessly westward. There's no land between here and North America. The ocean appears vast beyond comprehension, while the cliffs beneath one's feet feel suddenly narrow. This contrast has made the cliffs a place of reflection, often associated with thoughts of endings, beginnings, and transitions. Yet the cliffs are not merely symbolic. They are active, working landscapes. Erosion continues. Bird populations rise and fall. Climate change alters storm intensity and sea level. The cliffs respond constantly, even when they appear unchanged. At sunset, the cliffs take on a different character. Shadows deepen along the rock face. The ocean darkens. Light fades gradually from the western horizon, leaving the cliffs silhouetted against sky. In these moments, human presence often quiets. People linger, not speaking, watching the last light disappear. The cliffs seem less like a destination and more like a boundary between worlds. At night, with the visitors gone, the cliffs return to their oldest state, dark, wind-scoured, listening only to the Atlantic. Seabirds call, waves strike unseen rock, stars emerge above the edge. The cliffs do not sleep, but they endure. The Cliffs of Moher are not the highest cliffs in the world, nor the longest. Their significance lies elsewhere. They stand at a meeting point between land and ocean, past and present, human time and geological time. They are shaped by forces that ignore borders and lifetimes. They remind those who stand upon them that the earth is older, stronger, and more patient than any civilization. To visit the Cliffs of Moher is to stand at the edge of continuity, to see how slowly, relentlessly, the planet reshapes itself. Every layer of rock, every nesting bird, every wave crashing below participates in a process that began long before humans arrived and will continue long after they are gone. The cliffs do not rise to dominate the sky. They simply end the land. And in that ending, they reveal the scale of everything beyond. The sentinels of a falling coast. Along the southern edge of Australia, where the Southern Ocean meets the land with relentless force, a line of stone pillars rises from the sea. They stand offshore, isolated from the mainland, battered by waves, wind, and salt. Known today as the 12 Apostles, these limestone stacks are among the most recognized coastal formations on Earth, not because of their number, but because of what they represent. Erosion made visible, time accelerated by ocean power, and a coastline in the act of disappearing. Despite the name, there were never 12 apostles. At their most complete, there were 8 major stacks visible from shore. Today, fewer remain. What endures is not a count, but a process, one that has been unfolding for millions of years and continues every day, reshaping Australia's southern coastline in slow, unstoppable motion. The 12 Apostles are part of the Great Ocean Road coastline in Victoria, a stretch of land shaped by the collision of two immense forces, ancient limestone laid down in warm seas, and one of the most powerful oceans on the planet. The Southern Ocean sends uninterrupted swells across thousands of kilometers. There are no continents to weaken them. When those waves arrive here, they arrive fully formed. Geologically, the story begins around 20 million years ago, when this region lay beneath a shallow sea. Over time, marine organisms, shells, corals, microscopic plankton, settled on the seabed, their calcium-rich remains compacted into limestone, forming thick horizontal layers. These layers hardened slowly, preserving fossils and chemical signatures of an ancient ocean long gone. As tectonic forces lifted the seabed above sea level, the limestone was exposed to air and water. What followed was not sudden destruction, but patient erosion. Rainwater, slightly acidic, seeped into cracks. Waves exploited weaknesses. Over millions of years, the coastline retreated inland. Caves formed. Caves collapsed into arches. Arches collapsed into isolated stacks. The 12 Apostles are not structures that were built. They are remnants of what has already been lost. Seen from the cliff tops today, the stacks appear solid, permanent, monumental, but they are among the most fragile formations on the coast. Limestone is soft compared to granite or basalt. It fractures easily under constant wave pressure. Each stack stands only because surrounding rock has already been removed. Their isolation is proof of vulnerability, not strength. Originally, the formation was known as the Sow and Piglets, a name reflecting local maritime tradition. In the early 20th century, as tourism increased, the name was changed to the 12 Apostles, a title that carried symbolic weight and marketing appeal. The name stuck, even though the number never matched. Numbers matter less here than motion. Every year, storms remove small fragments from the stack's bases. Every decade, visible changes occur, and sometimes entire stacks collapse without warning. In July 2005, one of the largest stacks fell into the ocean overnight. Visitors returned the next morning to find it gone, reduced to rubble beneath the waves. No explosion, no ceremony, just gravity and erosion completing their work. The event shocked many, but for geologists, it was inevitable. These formations are temporary by nature. The cliffs from which the apostles were carved continue to erode as well. New caves form. New arches emerge. Future stacks are already being shaped out of the mainland. The coastline is not losing beauty. It is rearranging it. The Southern Ocean is central to this transformation. Winds from Antarctica drive massive swells toward the Australian coast. Waves strike the limestone base repeatedly, focusing energy into cracks and caves. Saltwater seeps into fissures, crystallizes, expands, and fractures the rock further. Storm surges lift wave impact higher up the cliffs, accelerating collapse. Unlike tropical coastlines shaped gently over time, this is a high-energy coast. Change happens faster here than in many parts of the world. Human presence along this coast is relatively recent. Indigenous peoples lived in the region for tens of thousands of years, moving seasonally along the coast, fishing, gathering shellfish, and reading the ocean's rhythms. Oral histories suggest awareness of shifting shorelines, collapsing cliffs, and dangerous waters. These were not static landmarks. they were known to change. European settlement arrived much later, and with it came shipwrecks. The coastline became known as the shipwreck coast, claiming hundreds of vessels during the 19th century. Poor visibility, strong currents, and hidden reefs made navigation treacherous. Many ships broke apart against the same limestone that now draws tourists. Remnants of these wrecks still lie offshore, scattered along seabed, slowly corroding. They form part of same narrative as the Apostles, evidence of the ocean's authority. The 12 Apostles gained global recognition with development of the Great Ocean Road, built between 1919 and 1932 by returned soldiers as war memorial. The road connected remote coastal communities and opened region to visitors. With access came attention, photography, and eventually mass tourism. Today, visitors arrive from around the world to view the stacks from clifftop platforms. Helicopters fly overhead. Cameras point constantly towards sea. Yet, despite human activity, the formations remain indifferent. They do not respond to admiration. They respond only to physics. The viewing platforms are carefully positioned away from unstable edges. Landslides and cliff collapses occur regularly. Warning signs remind visitors that the ground beneath their feet is temporary. This is not metaphor. The land is actively retreating. Ecologically, the stacks and surrounding waters support diverse marine life. Seals rest on submerged rock platforms. Seabirds nest on cliff ledges. Kelp forests grow beneath surface, feeding fish populations. The cold, nutrient-rich waters of southern oceans support a productive ecosystem, even as waves make surface appear hostile. At dawn, light reveals textures invisible during day. Limestone glows pale gold. Shadows stretch across waves. In calm weather, the stacks appear serene, rising quietly from glassy sea. But calm is deceptive. Weather can change within minutes. Wind accelerates. Swells rise. Spray explodes against rock. Sunset brings another transformation. The limestone absorbs warm hues, orange, red, purple. The ocean darkens. Silhouettes sharpen. This fleeting beauty contrasts sharply with the violent forces shaping the coast. At night, when visitors leave, the coast returns to its original rhythm. Waves strike unseen rock. Wind scours cliff faces. Salt hangs in air. The Apostles stand alone again, illuminated only by moon and stars. In darkness, it becomes easier to imagine their future absence. Scientists monitor the coastline using aerial surveys, laser scanning, and historical photography. Comparisons show dramatic retreat over the last century alone. In some areas, the cliff edge has moved inland by several meters. This retreat will continue regardless of human intervention. Climate change adds uncertainty. Rising sea levels increase wave reach. More intense storms deliver greater energy to cliff bases. Erosion accelerates. The lifespan of remaining stacks shortens. There's no plan to preserve the Apostles physically. No reinforcement, no seawalls. Authorities recognize that preservation would contradict their nature. These are not monuments to be maintained. They are processes to be observed. This understanding shapes conservation philosophy. The goal is not to freeze landscape in time, but to allow it to change safely and visibly, while protecting visitors and ecosystems. The 12 Apostles endure because they are incomplete. They are mid-transition. They exist in moment between arch and collapse. Their drama lies not only in presence, but in inevitability. Few natural landmarks make time so visible. Standing on the cliffs, one does not simply look at stone. One looks at history dissolving in real time. One sees past cliffs already gone, current stacks weakening, and future formations emerging offshore. The coastline tells story forward and backward simultaneously. This awareness often produces silence among visitors. Conversations quiet. People linger longer than expected. The cliffs command attention not through height, but through finality. There's nothing beyond them but ocean. In this way, the 12 Apostles resemble the Cliffs of Moher, yet differ profoundly. Moher presents wall against sea. The Apostles present fragments already separated. One shows resistance, the other shows surrender. Both are honest records of erosion. Over centuries, the Apostles will vanish completely. New stacks will form elsewhere. Names will change. Photographs will preserve moments that no longer exist, but the process will remain. The Southern Ocean will continue to arrive. Limestone will continue to break. Land will continue to retreat. and humans will continue to stand at the edge, watching Earth reshape itself. The 12 apostles are not symbols of endurance. They are symbols of change. They do not rise to challenge the ocean. They stand because they have not yet fallen. And in that fragile balance, they remind us that landscapes are not static backdrops. They are active participants in time itself. The Forest of Stone. In northwestern Hunan province, China, a landscape rises that appears to defy gravity and scale. Thousands of slender stone pillars surge upward from dense forest, their tops often hidden in drifting mist, their bases swallowed by green valleys far below. This is Zhangjiajie, home to the world's largest concentration of sandstone pillar formations, a place where erosion did not flatten the land, but sharpened it into vertical architecture. At first glance, the pillars look artificial, as if sculpted deliberately. They stand close together, tall and narrow, separated by deep ravines and sheer drops. Some rise more than 200 meters high, yet measure only a few meters across at their narrowest points. Clouds weave between them, giving impression that stone itself is floating. But Zhangjiajie is not illusion. It is the result of slow geological forces acting with rare precision over hundreds of millions of years. The foundation of this landscape was laid during the Devonian period over 400 million years ago, when the region lay beneath a shallow sea. Layers of quartz-rich sandstone accumulated gradually, compacted under pressure, and cemented into solid rock. Unlike softer sedimentary layers that erode evenly, this sandstone contained vertical fractures and joints, weaknesses that would later define the landscape. When tectonic uplift raised the region above sea level, erosion began its work. Rainwater infiltrated fractures, rivers cut downward, wind and temperature changes widened cracks. Over immense spans of time, broad plateaus were carved into narrow ridges. Those ridges became towers. What remains today are the hardest cores of the original rock mass, stone survivors of a long collapse. Zhangjiajie's pillars are not mountains in the traditional sense. They are erosional remnants, the last standing pieces of a once continuous sandstone plateau. Everything else has been carried away, grain by grain, by water and gravity. This type of landscape is rare. Similar formations exist in parts of Utah and Brazil, but nowhere on Earth do sandstone pillars appear in such density or scale. More than 3,000 pillars rise across the region, forming a stone forest unlike any other. The verticality of Zhangjiajie creates a unique environment. Valleys between pillars remain shaded for much of the day, trapping moisture and supporting dense subtropical vegetation. Ferns, mosses, and trees cling to steep slopes. The tops of pillars experience stronger winds and greater exposure, supporting different plant communities. This vertical separation creates multiple ecosystems stacked within a small horizontal area. Fog and mist play a critical role. Moist air from valleys rises and condenses around the pillars, feeding plant life and accelerating chemical weathering of the rock. This mist is not just visual phenomenon, it is active agent shaping stone. For centuries, the region remained isolated. Sheer terrain made large-scale settlement difficult. Local Tujia and Miao communities lived in surrounding valleys, navigating the landscape through narrow paths and passes. For them, the pillars were part of lived environment, not spectacle. They were landmarks, weather indicators, spiritual symbols. Traditional folklore describes the pillars as petrified warriors, guardians, or spirits frozen in stone. These stories reflect natural human response to vertical forms that resemble figures standing in silence. The idea of stone watching from above is deeply embedded in local myth. Outside the region, Zhangjiajie remained largely unknown until the 20th century. In 1982, it became China's first national forest park. Later, it was designated a UNESCO Global Geopark. With protection came access, roads, trails, and eventually visitors from around the world. The transformation was dramatic. What was once remote became globally recognized, especially after the landscape inspired the floating mountains seen in the film Avatar. Though the film exaggerated reality, it captured something true, the sense that Zhangjiajie belongs to another world. But behind cinematic imagery lies real geology, still changing. The pillars continue to erode. Rainwater dissolves minerals. Freeze-thaw cycles expand cracks. Entire sections occasionally collapse, sending rock down into valleys. These events are rarely noticed by visitors, but they are constant reminders that the pillars are temporary structures. Unlike cliffs that retreat evenly, Pillars fail individually. One may stand for thousands of years. Another may collapse suddenly. The forest of stone is always rearranging itself. Human access to the area is carefully managed. Walkways cling to cliff sides. Glass-bottom bridges span valleys. Cable cars carry visitors to elevated viewpoints. While these structures allow people to experience the landscape, they also emphasize how inaccessible it once was, and still is, beyond designated paths. One of the most striking experiences in Zhangjiajie is elevation change. From valley floor, pillars loom impossibly tall. From above, they drop away beneath one's feet. Depth perception shifts constantly. Distances are deceptive. The landscape resists simple understanding. Sound behaves differently here. Wind funnels through narrow gaps, creating low whistles and sudden gusts. Rain echoes off stone walls. In fog, visibility shrinks to meters, and pillars appear suddenly, then vanish again. Orientation becomes difficult. It's easy to imagine how travelers once became lost among them. Biologically, the area is rich. More than 700 plant species grow here, including ancient relic species that survived past climate shifts. Rare animals inhabit the forest, including macaques, salamanders, and birds adapted to vertical terrain. The pillars provide refuge from human expansion, preserving biodiversity in a rapidly developing region. But tourism brings pressure. Millions now visit annually. Foot traffic compacts soil. Infrastructure alters water flow. Authorities monitor erosion rates, vegetation health, and rock stability. Conservation efforts aim to balance access with preservation, a difficult task in landscapes so fragile and so popular. Weather patterns add another layer of complexity. Zhangjiajie lies in humid subtropical zone. Heavy rainfall accelerates erosion, but also sustains vegetation that stabilizes slopes. Climate change threatens to disrupt this balance. More intense rainfall could increase landslides. Drought could reduce plant cover, exposing rock. Yet, despite all change, the pillars retain sense of permanence when viewed together. Individually fragile, collectively immense. Their power lies in number and repetition. An army of stone rising from forest. At sunrise, first light touches pillar tops, leaving valleys in shadow. Mist thickens, then thins. The pillars appear to rise and sink as clouds move. By midday, sunlight reveals textures, vertical grooves, ledges, fractures, evidence of erosion in progress. At dusk, silhouettes sharpen, and the forest darkens below. At night, the pillars become nearly invisible. Without light, only outlines remain. Wind moves unseen, forest sounds rise. The stone forest returns to state it knew long before visitors arrived. Scientifically, Zhangjiajie offers rare opportunity to study long-term erosion in vertical systems. Researchers analyze fracture patterns, mineral composition, and weathering rates. Laser scanning maps pillar shapes with millimeter precision, allowing scientists to track change over time. These studies help predict future collapses and guide conservation planning. Culturally, Zhangjiajie represents shift in how landscapes are valued. Once overlooked due to inaccessibility, it is now globally celebrated. But this celebration raises questions. How much exposure can fragile landscapes endure? How do we preserve places defined by erosion without interfering with erosion itself? There's no simple answer. What is clear is that Zhangjiajie cannot be frozen in time. Its beauty depends on change. To stop erosion would be to erase what made it. Visitors who linger long enough often sense this. Initial excitement gives way to quiet observation. The pillars seem less like monuments and more like processes, snapshots in long sequence of transformation. The forest of stone does not tell a story of creation alone. It tells a story of subtraction, of what remains after nearly everything else has been removed. Zhangjiajie exists because erosion didn't finish its work, and one day it will. Long after current walkways decay, long after photographs fade, water will continue to find cracks, gravity will continue to pull, and pillars will continue to fall, one by one, back into forests that will reclaim their remains. Until then, they stand, not as symbols of permanence, but as witnesses to time made vertical. A landscape carved not by sudden catastrophe, but by patience beyond human scale. Zhangjiajie does not rise to dominate the world. It rises because the world around it disappeared, and in that quiet truth, The stone forest reminds us that Earth does not build monuments, it leaves evidence. The coast that became a sculpture. Along the northern coast of France, where the English Channel narrows and tides move with quiet force, white cliffs rise from the sea with a geometry that feels deliberate. From a distance, they appear smooth and continuous, glowing pale against gray water and sky, but closer inspection reveals interruptions. Vast openings cut cleanly through the rock, arches so large they frame the ocean itself. This is Etretat, a coastline shaped not by sudden catastrophe, but by slow persistence, where chalk has been carved into some of Europe's most recognizable natural forms. The chalk cliffs of Etretat stretch along Normandy's alabaster coast, a name derived from their color rather than composition. They are not marble or limestone in the conventional sense, but chalk, a soft, porous sedimentary rock made almost entirely of microscopic marine organisms. Each grain represents a shell, a skeleton, a fragment of ancient life that settled on seabed more than 90 million years ago, during the late Cretaceous period. At that time, this region lay beneath a warm, shallow sea. Countless coccolithophores, tiny plankton with calcium carbonate plates, lived, died, and sank to ocean floor. Over millions of years, their remains accumulated in immense thicknesses. Pressure compacted them into chalk, layer upon layer, interspersed with thin bands of flint formed from silica-rich organisms. These flint seams would later play a decisive role in shaping the cliffs. When tectonic uplift raised the seabed above sea level, the chalk plateau became land. Rain, frost, and waves began their work. Chalk is easily eroded by water, dissolving slowly under chemical action. Flint, by contrast, is hard and resistant. This difference created internal weaknesses, planes along which erosion could proceed unevenly. The sea exploited those weaknesses. Over millennia, waves struck the base of the cliffs relentlessly. The English Channel may appear calmer than open oceans, but tidal forces here are strong, and storms driven from the Atlantic deliver powerful swells. Each wave applied pressure, widened cracks, and removed chalk grain by grain. Where fractures aligned vertically, caves formed. Where caves deepened, arches emerged. Where arches grew too thin to support their own weight, collapse followed. This sequence, cliff to cave to arch to stack, stack to ruin, defines the evolution of Etretat's coastline. Today, 3 major arches dominate the landscape. The Port d'Aval, the largest, opens toward the southwest, its span framing open sea. Nearby stands L'Aiguille, a slender needle of chalk rising more than 50 meters from the water, a remnant stack left behind by erosion. Further along lies the Port d'Amont, facing northeast, more compact but equally striking. These formations are not anomalies. They are stages in an ongoing process. What makes Etretat remarkable is clarity. The chalk's pale color, the arch's clean outlines, and the relatively uniform cliff face make erosion easy to read. The coastline functions as a geological diagram, a visible explanation of how land yields to sea. But this clarity is deceptive. Chalk cliffs are among the most unstable coastal formations in Europe. Rockfalls occur frequently, often without warning. Entire sections collapse after heavy rain, frost, or prolonged wave action. The cliffs retreat inland at a steady rate, measurable over decades. What appears unchanged from year to year is in constant motion. The town of Etretat sits just behind this moving edge. Its relationship with the cliffs has always been one of proximity and caution. Fishermen once launched boats from pebble beaches below the arches, hauling vessels up by hand to escape tides. These pebbles, rounded flintstones eroded from chalk, accumulate because chalk dissolves, leaving flint behind. Over time, waves polish flint into smooth oval stones that blanket the shore. These beaches, though visually striking, are difficult to walk on and dangerous during storms. Waves can surge unexpectedly, trapping the unwary against cliff walls. The same forces that carved the arches still operate at human timescales. Etretat entered global imagination largely through art and literature. In the 19th century, painters like Claude Monet returned repeatedly, capturing the cliffs in different light and weather. Monet painted the arches dozens of times, documenting how color, shadow, and atmosphere transformed the same forms. Writers followed. Guy de Maupassant, who grew up nearby, described the cliffs as living beings, changing mood with sea and sky. These artistic interpretations cemented Etretat's image as romantic landscape. But romance coexists with reality. The cliffs are indifferent to beauty. They collapse, whether admired or not. The flint layers embedded within chalk add another dimension. When chalk erodes, flint remains, falling onto beaches or protruding from cliff faces like dark scars. These flints were used by prehistoric humans for tools, linking geological process to human history. Archaeological evidence shows people living near these cliffs tens of thousands of years ago, exploiting coastal resources while navigating unstable terrain. In medieval times, the cliffs served as natural barriers and navigational landmarks. Their white faces were visible from far out at sea, guiding ships toward the Norman coast, but they also concealed dangers: submerged rocks, unpredictable tides, sudden storms. Shipwrecks were common along this coast, and remnants lie scattered offshore. From above, the cliffs appear orderly, almost architectural. Paths trace their tops, offering views across channel toward England on clear days. But safety barriers mark unstable zones, and warning signs remind visitors that the edge is temporary. Every meter of land here is borrowed from future sea. Modern science monitors the cliffs closely. Laser scanning, aerial photography, and historical mapping reveal rates of erosion. Comparisons show that the coastline has retreated significantly since the Middle Ages. Entire arches that once existed are gone. New caves are forming where solid cliff once stood. Climate change introduces new variables. Rising sea levels allow waves to strike higher on cliff bases. Increased storm intensity delivers more energy per impact. Changes in freeze-thaw cycles affect chalk stability. All these factors accelerate processes already underway. Yet there is no plan to halt erosion. Authorities recognize that intervention would only shift problem elsewhere or destroy natural character. Instead, the focus is on risk management, moving paths inland, controlling access, documenting change. Etretat is therefore not preserved as static monument. It's preserved as evolving system. Ecologically, the cliffs support specialized plant communities adapted to chalk soils. Thin grasses, hardy flowers, and lichens cling to the edge, their roots shallow but persistent. Seabirds nest on ledges and in crevices, exploiting vertical refuge. Gulls, kittiwakes, and cormorants circle the arches, their calls echoing off stone. Below waterline, algae and marine organisms colonize submerged chalk, contributing to biological erosion. Life participates in breakdown of rock as much as waves and weather. The experience of standing before the arches is shaped by movement. Tides rise and fall dramatically in the channel. At low tide, beaches widen, revealing flint fields and exposing bases of arches. At high tide, waves fill openings, transforming arches into temporary gates of water and foam. Light alters perception constantly. Morning sun illuminates cliff faces from east, flattening relief. Afternoon light sharpens shadows. Overcast skies mute color, emphasizing form. In fog, arches emerge and disappear, their scale hard to judge. At sunset, chalk absorbs warm tones, turning pale gold and then pink. As light fades, arches become silhouettes against darker sea. This daily cycle reinforces sense that landscape is active participant in time, not static backdrop. One of Etretat's most enduring associations is the idea of absence. Each arch represents not only presence of stone, but absence of what once existed. Every opening marks removal. This makes the landscape feel incomplete by design, as if something is always missing. That sensation has psychological impact. Visitors often describe a mix of awe and unease. The arches are beautiful, but they are also reminders of loss. What stands now will not stand forever. What has already fallen cannot be recovered. This awareness distinguishes Etretat from many other coastal landmarks. It does not present permanence. It presents process. The Needle of Leguy exemplifies this. It is isolated, slender, and clearly transitional. It will not last. Its base continues to erode. One day, it will fall, joining countless unnamed stacks that already lie beneath the waves. When that happens, new formations will begin elsewhere. The coast will not become empty. It will become different. Etretat teaches a lesson common to many great natural structures, but unusually visible here. Erosion is not destruction alone. It is creation through removal. Without erosion, there would be no arches. Without collapse, no needles. Without loss, no form. The chalk cliffs continue to retreat inland, but the story they tell remains clear. They are records of ancient seas, of tectonic uplift, of wave energy, of chemical dissolution. They are evidence that even the softest rock can stand tall for millions of years, and that even the tallest forms eventually yield. In a world increasingly engineered and stabilized, Etretat remains honest. It does not hide instability. It displays it openly, carved into white stone. The coast here does not end abruptly like a wall. It opens into arches, into sky, into sea. It allows passage, both physical and conceptual, reminding observers that boundaries are rarely fixed. Standing at Etretat, one sees land in negotiation with water. Neither wins permanently. Each advances, retreats, reshapes. The arches do not frame the ocean to glorify it. They exist because the ocean has already passed through them. They are monuments not to resistance, but to endurance through change. And in their slow transformation, they show how landscapes tell time, not in years or centuries, but in layers, gaps, and openings left behind. The bay where stone floats, along the northeastern coast of Vietnam, where the Gulf of Tonkin meets the land, thousands of stone towers rise from the sea. Some stand alone, others cluster tightly, their bases hidden beneath green water, their summits crowned with vegetation. From a distance, they appear to float, dark silhouettes suspended between sky and sea. This is Ha Long Bay, one of the most extensive and visually striking karst landscapes on Earth. Ha Long Bay contains more than 5,600 limestone islands and pillars, spread across an area of roughly 5,500 square kilometers. Unlike mountain ranges that dominate the horizon, these formations are scattered, fragmented, and irregular. They do not form a wall or ridge. Instead, they punctuate the water like remnants of a broken continent. The name Ha Long translates to descending dragon, rooted in local legend. According to tradition, dragons were sent by the gods to defend the land from invaders. They descended from the sky, spitting jewels that became islands, forming a natural barrier against approaching ships. When the danger passed, the dragons remained, and the bay took its present form. Myth aside, Ha Long Bay is the product of one of Earth's most powerful and patient geological processes, karstification. The limestone that forms Ha Long Bay began accumulating more than 300 million years ago, when the region lay beneath a warm, shallow sea. Marine organisms with calcium carbonate shells lived, died, and settled on the seabed, building thick layers of limestone over immense spans of time. These deposits hardened into rock long before the bay itself existed. Later, tectonic uplift raised the limestone above sea level. What followed was not dramatic upheaval, but slow chemical erosion. Rainwater absorbed carbon dioxide from the air and soil, becoming weak carbonic acid. Over thousands and then millions of years, this slightly acidic water seeped into cracks in the limestone, dissolving it from within. This process did not erode the rock evenly. Water followed fractures, joints, and bedding planes, widening them gradually. Solid limestone mass was separated into blocks. Valleys deepened. Towers emerged where rock remained strongest. Eventually, rising sea levels flooded the lowlands, leaving the higher limestone remnants standing as islands. What we see today is not construction, but residue, the surviving framework of a much larger limestone platform that has mostly vanished. Ha Long Bay is part of a broader karst system extending across southern China and Southeast Asia, but its defining feature is interaction with the sea. Many karst landscapes form on land, with towers rising from plains. In Ha Long Bay, water fills the voids between towers, amplifying their isolation and visual impact. The towers vary greatly in size and shape. Some are tall and narrow, others squat and broad. Many contain caves at their bases or within their interiors, formed where water dissolved limestone more aggressively. These caves range from small sea-level openings to vast chambers hidden deep inside islands. Among the most famous are Sung Sat Cave, Tien Kung Cave, and Dao Go Cave, each revealing interior landscapes of stalactites, stalagmites, and flowstone shaped by dripping water. These caves are not static. Mineral-rich water continues to deposit calcium carbonate, slowly altering formations even today. At sea level, erosion remains active. Waves undercut island bases, creating overhangs and arches. Some towers have collapsed entirely, leaving submerged debris fields. Others have split into smaller pillars. The bay is constantly rearranging itself, though changes are subtle on human timescales. Despite this activity, Halong Bay feels calm compared to open coasts. The islands break wave energy, creating sheltered waters where boats move smoothly. This calmness has allowed human presence for tens of thousands of years. Archaeological evidence shows that prehistoric people inhabited caves along the bay as early as 18,000 years ago. These communities relied on fishing, shellfish gathering, and coastal foraging. Stone tools, bone remains, and hearths discovered in caves indicate long-term occupation. The bay provided protection, food, and navigational reference. As sea levels rose after the last ice age, some of these cave sites were flooded, preserving evidence underwater. Researchers continued to study submerged archaeology to reconstruct how early humans adapted to shifting coastlines. Throughout Vietnamese history, Halong Bay has served as both shield and corridor. Its maze-like layout made navigation difficult for outsiders unfamiliar with tides and channels. During several conflicts, including battles against invading fleets, the bay's geography played a defensive role. Narrow passages, hidden reefs, and sudden shallows could trap or disable ships, yet the bay was never isolated. Trade routes passed through the Gulf of Tonkin, connecting Vietnam to China and Southeast Asia. Fishermen established floating villages among the islands, living on boats or rafts anchored in sheltered coves. These communities adapted to tides, storms, and seasonal changes, developing intimate knowledge of the bay's rhythms. The limestone towers also support unique ecosystems. Vegetation clings to their steep sides, rooted in thin soils formed from weathered rock and organic debris. Trees and shrubs grow atop islands, their roots penetrating cracks in limestone. Over time, these roots widen fractures, contributing to biological erosion. This interplay between geology and biology is essential to the bay's evolution. Plants accelerate breakdown of rock. Birds nest on ledges, depositing nutrients. Marine organisms bore into submerged limestone. Life and erosion operate together. Halong Bay's waters support coral reefs, seagrass beds, fish, crustaceans, and mollusks. The sheltered environment allows biodiversity to flourish. But this balance is delicate. Changes in water quality, temperature, or sediment load can disrupt marine life quickly. In modern times, Halong Bay has become one of Vietnam's most visited destinations. Cruise boats traverse channels. Kayaks slip between towers. Visitors explore caves and viewpoints. Like many iconic landscapes, popularity brings pressure. Tourism infrastructure has expanded rapidly. Boat traffic increases noise and pollution. Waste management is an ongoing challenge. Authorities regulate routes, limit access to certain areas, and monitor water quality. UNESCO World Heritage status, granted in 1994, has helped focus conservation efforts, but balancing economic benefit with environmental protection remains complex. The limestone itself is fragile. Karst landscapes are particularly vulnerable to human disturbance. Small changes in water chemistry or flow can accelerate dissolution. Physical damage to cave formations is irreversible on human timescales. Despite management efforts, the bay continues to change. Climate change introduces additional stress. Rising sea levels alter erosion patterns at island bases. Stronger storms deliver greater wave energy into previously sheltered areas. Ocean warming affects coral ecosystems. Increased rainfall can intensify chemical weathering of limestone. Yet, even with these pressures, Halong Bay retains its defining character, a landscape of separation and survival. Each tower stands because surrounding rock has already been removed. Their presence is evidence of loss rather than accumulation. This characteristic creates powerful visual effect. When mist settles over the bay, towers emerge and disappear, giving impression of movement. Depth perception becomes unreliable. Distances flatten. The bay feels larger than it is. Layered with space, sound behaves differently here. Engines echo between stone walls. Wind funnels through channels. In quieter moments, water laps softly against rock, amplified by enclosed spaces. At night, with boat lights reflecting off limestone, the towers become silhouettes again, returning to their original anonymity. Geologically, Halong Bay offers insight into long-term landscape evolution under humid tropical conditions. Karstification proceeds faster here than in colder climates. Heavy rainfall, warm temperatures, and abundant vegetation accelerate chemical weathering. What took hundreds of millions of years to build can be reshaped relatively quickly. Scientists use Ha Long Bay as natural laboratory to study karst processes, sea level change, and coastal geomorphology. Comparing satellite imagery over decades reveals subtle shifts in island outlines. Laser scanning captures cave interiors in high detail. These data help predict future changes and guide conservation. But perhaps the bay's most enduring impact is experiential. Visitors often describe a sense of disorientation followed by calm. The lack of straight lines, the repetition of forms, the muted color palette of stone, water, and sky create meditative atmosphere. The bay does not overwhelm through height or scale alone. It envelops. Unlike single monoliths or cliffs, Ha Long Bay is immersive. One does not look at it from outside, one moves through it. The landscape surrounds rather than confronts. This immersion reinforces a key truth. Ha Long Bay is not static scenery. It is system in motion. Islands erode, channels widen, caves expand, towers fall, new shapes emerge. The bay exists in balance between persistence and dissolution. Some towers will collapse within centuries. Others may stand for millennia. None are permanent, but the process that creates them will continue as long as limestone, water, and time coexist. The dragons of legend may not be real, but the idea they represent, immense force-shaping land, is accurate. Ha Long Bay is a record of descent, not ascent. Its towers rise because everything around them fell away. They are not mountains. They are remnants. They do not float because they are light. They float because the land beneath them disappeared. In this way, Ha Long Bay mirrors many of Earth's greatest natural structures. It teaches that landscapes are archives of loss as much as creation. What remains visible is shaped by what is gone. Standing on the deck of a boat as towers slide past, one witnesses geology at work in real time. Slow, patient, unstoppable. The bay does not ask to be conquered or climbed. It asks to be read. And if read carefully, it tells a clear story. That water, given enough time, reshapes stone. That separation can create beauty. And that even the most solid forms exist on borrowed time. Ha Long Bay is not a place where stone defies the sea. It is a place where stone has already yielded and continues to do so. The arch that time took back. On the western edge of the island of Gozo, where the Mediterranean opens wide and the seabed drops sharply into deep water, a natural arch once stood that seemed almost permanent. Carved from pale limestone and framed against open sea, the Azure Window was for decades one of the most recognizable coastal formations in Europe. It rose directly from the water, its curved span connecting land to land, rock to rock, sky to sea. And then, in a single storm, it disappeared. What remains today is not an arch, but a coastline, fractured, exposed, and still changing. The story of the Azure Window is not only about collapse. It is about geology, erosion, and the illusion of permanence. It is a lesson written clearly in stone, then erased. The Cliffs of Moher Bay belong to a much older story than the brief human memory of the arch itself. Gozo, the smaller sister island of Malta, is composed almost entirely of sedimentary limestone laid down between 30 and 5 million years ago, when the region lay beneath warm, shallow seas. Layer upon layer of marine sediment accumulated slowly, compacting into rock rich with fossilized shells, corals, and microorganisms. These limestone layers formed in relatively calm environments, reefs, lagoons, and seabeds, producing rock that is soft compared to granite but durable enough to stand in large formations. Over millions of years, tectonic uplift raised these layers above sea level, tilting and fracturing them. The Mediterranean Sea then became the dominant sculptor. At Moher Bay, the coastline is exposed to open water from the west. Waves here are not softened by long continental shelves. Storm energy travels far across the sea and strikes the cliffs with full force. The interaction between limestone and wave energy is the foundation of everything that followed. The Azure Window did not appear suddenly. It evolved through a familiar coastal sequence. First, a section of limestone cliff weakened along fractures. Waves exploited these weaknesses, carving a sea cave into the rock. Over time, the cave deepened and expanded until it broke through to the other side, forming an arch. The roof of the arch was always under stress, held up by stone already thinned by erosion. For centuries, the structure endured. Its shape changed subtly, its edges softened, its underside hollowed further by waves. To human observers, it appeared stable. To geology, it was already failing. Nearby, other formations tell parallel stories. The inland sea, a shallow lagoon connected to open water by a narrow tunnel, was also formed by collapse of cave roofs. The fungus rock, a tall islet nearby, stands as another erosional remnant, isolated, sheer, and historically protected due to a rare medicinal plant once believed to grow there. These features illustrate that Dwedra is not a place of static landmarks, but of ongoing transformation. The Azure Window entered modern consciousness in the 20th century, becoming emblem of Malta's natural beauty. It appeared in films, television series, and countless photographs. Visitors walked along its top, stood beneath its span, and swam through its opening. Despite warning signs, human interaction increased stress on already fragile structure. Geologists repeatedly cautioned that the arch was unstable. Cracks widened, portions fell from underside. Access to the top was officially discouraged, then restricted. But restrictions came late. The arch was already at end of its lifespan. On March 8, 2017, after days of heavy storms, the Azure Window collapsed completely. Witnesses described a roar, then a cloud of spray. The entire arch fell into the sea, leaving behind only the supporting pillars and a rough, uneven coastline. Within minutes, one of Europe's most photographed natural landmarks ceased to exist. The collapse shocked the public, but for scientists, it confirmed predictions. The arch had not been destroyed by one storm alone. That storm simply delivered final stress to a structure weakened over thousands of years. What remains at Dwedra today is a raw landscape. Without the arch, the cliffs appear more exposed. The shoreline reveals broken limestone shelves, wave-cut platforms, and collapsed debris fields beneath the surface. Divers explore submerged blocks that once formed the arch's roof, now scattered across the seabed. The absence itself has become focal point. Visitors arrive expecting to see the arch and instead confront empty space. This absence forces reconsideration of how landscapes are perceived. The Azure Window is now remembered rather than observed, a geological process interrupted only briefly by human attention. From scientific perspective, the collapse provided valuable data. Comparing photographs, scans, and geological surveys before and after the event has improved understanding of coastal erosion rates in limestone environments. The site illustrates how wave energy concentrates beneath arches, hollowing structures invisibly until collapse becomes inevitable. The cliffs around Dwedra continue to erode. New caves form, roofs thin. Future arches may emerge elsewhere along the coast, only to follow the same path. There is no endpoint, only cycles. Ecologically, the area remains active. Marine life colonizes submerged rockfalls quickly. Algae and corals attach to fresh limestone surfaces. Fish shelter among newly fallen blocks. What appears as destruction on land becomes opportunity underwater. Above water, seabirds continue to nest along cliffs. The absence of the arch has not diminished the bay's ecological role. Instead, it has shifted patterns of wind, spray, and wave reflection slightly. Small changes, but measurable ones. Culturally, the loss of the Azure Window sparked debate. Some called for reconstruction. Others proposed artificial replacements. Authorities rejected these ideas, recognizing that recreating a natural feature would undermine its meaning. The value of the arch lay in its authenticity, and its loss reinforces that authenticity. The decision reflects a broader shift in how natural heritage is understood. Preservation does not mean freezing landscapes in time. It means allowing them to change while managing risk and impact. At Dwedra, paths have been rerouted, viewing areas adjusted, and interpretation updated to explain erosion rather than hide it. Standing at the edge of the cliffs today, one sees a different kind of spectacle. Waves strike exposed rock with clarity. The coastline feels unfinished. The eye searches instinctively for the missing arch. In its absence, the processes that created it become more visible. Light still transforms the cliffs throughout the day. The limestone glows pale under Mediterranean sun. At sunset, shadows deepen across broken edges. The sea remains restless. The inland sea still breathes with tides through its narrow tunnel. At night, the bay returns to darkness and sound. Waves echo through cavities. Wind scours the cliff tops. The memory of the arch fades. replaced by raw interaction between stone and water. The Azure Window's story resonates because it contradicts expectation. Iconic landscapes are assumed to endure, but geology does not respect recognition. The same forces that created the arch removed it without regard for cameras or calendars. This realization challenges how humans relate to nature. We are accustomed to cataloging landmarks as permanent features. The collapse of the Azure Window demonstrates that even the most celebrated formations exist on borrowed time. In a broader context, the event parallels losses elsewhere: collapsing stacks on Australia's coast, retreating chalk cliffs in France, eroding limestone towers in tropical bays. Dwedra Bay is not exception. It is example. The cliffs of Gozo continue to tell their story quietly. They speak of ancient seas, of uplift and fracture, of waves shaping rock grain by grain. They also speak of human attention, brief, intense, and ultimately temporary. The Azure Window is gone, but its lesson remains visible in the exposed rock faces, the scattered blocks beneath the sea, and the process is still unfolding along the coast. Landmarks do not disappear when they collapse. They change form. The arch no longer frames the sea, but the sea still frames the land. And in that absence, Dwedra Bay offers one of the clearest lessons geology provides: that nature does not preserve its own creations. It replaces them. What was once admired as a finished sculpture is now understood as moment in a much longer story. The Azure Window was never meant to last. It was meant to exist long enough to be noticed, and then to return to the sea that shaped it. Thank you for exploring Earth's fragile giants with us. If this journey moved you, please like, subscribe, and share where you're watching from. It helps others find these stories. Until next time, may the changing edges of our world stay with you.